Within our comprehensive range of EPSITRON power supplies, let's have a look at how WAGO's electronic circuit breakers, ECBs, provide better system protection. First, let's compare thermomagnetic circuit breakers to ECBs. Let's have a look at the trip characteristics of thermomagnetic circuit breakers. Their trip behavior depends on the overload. Thermotripping is time-delayed on low overloads. On large overloads, however, magnetic tripping interrupts the circuit very quickly. In contrast, WAGO's ECBs are a lot more intelligent. They continuously measure the actual current, and the reaction time depends on the overload. As can be seen from an ECB's trip curve, a certain trip time can be guaranteed. This tripping function makes ECBs more reliable than thermomagnetic circuit breakers, particularly under low overcurrent conditions. Let's talk about selectivity. Selectivity allows an overloaded circuit to be shut down without affecting the other parts of the system. Now let's look at the thermomagnetic circuit breakers more closely. Looking at the trip curve with the characteristics B, C, or D, we might think that selectivity is always guaranteed. In reality, this is not the case, especially under low overcurrent conditions. In fact, thermotripping of thermomagnetic circuit breakers takes too long to shut down overloaded channels. As a result, the upstream power supply unit activates its overcurrent protection and reduces its output voltage. This can cause the entire control cabinet to shut down. Let's take a circuit breaker with trip characteristic C as an example. To guarantee fast tripping, 10 times the circuit breaker's nominal current would be necessary. This may even be 12 to 15 times at a DC current. The trip time may also vary between 0.02 and 8 seconds. In most cases, the power supply unit will limit the current before a thermomagnetic circuit breaker trips. Now let's look at how ECBs behave. As previously mentioned, ECBs continuously measure the actual current. This allows them to quickly detect an overcurrent and switch off the affected current path before the power supply shuts down and other current paths are affected. For example, in the event of an overcurrent being 10 times higher than the nominal current, ECBs will trip after only 100 milliseconds. The ECBs therefore provide superior shutdown selectivity, even on low overloads. Unlike thermomagnetic circuit breakers, ECBs are configurable. Both the nominal current and related trip curve can be set separately for each channel. ECBs also require significantly less space. As this example shows, an ECB may replace up to 8 thermomagnetic circuit breakers. The space required is therefore reduced from 140 to 42 millimeters in width. This space savings means that control cabinets can be even more compact. Furthermore, the ECBs provide significantly better protection, even with long wire lengths. The cable resistance, which increases proportionally to the wire length, limits the current that can flow in the wire. For example, suppose that the wire resistance in this current is 2 ohm. This means that the current cannot exceed 12 ampere in this circuit. Let's first have a look at a thermomagnetic circuit breaker featuring a nominal current of 2 ampere and trip characteristic C. Such a circuit breaker requires 10 times the nominal current to trip, that is 20 ampere. Due to the cable resistance, this value can never be reached, and the thermomagnetic circuit breaker cannot perform its protective function. However, if we use an ECB, it will permanently measure the current in the faulty circuit and switch it off after a certain time, depending on the value of the measured current. This period of time is 100 milliseconds with a current of 12 ampere. ECBs can also be controlled remotely. This allows, for example, trip channels to be switched on again from outside the system. A connected PLC can switch on or off channels arbitrarily when needed via the communication. Let's summarize. ECBs are more reliable than thermomagnetic circuit breakers. They provide a better shutdown selectivity even on low overloads. They keep their protective functions, even with installations requiring long wires, offer more functions, and save space in the control cabinet. They are also configurable, which helps to lower storage costs. Their communication capability permits both remote diagnostics and remote control.